Hello everyone, welcome back to my channel. So in the last video of this AI project, we have done we have downloaded the data set using the SHAP library. So this is an adult census database which has a label of income is more than 50K per year or not. So we have performed many statistical operation. We also display the histogram for that, and now we will continue ahead. So in today's video, we are going to split the database into multiple section for different purposes. So we are going to use that. And so we are going to split our database into three parts. So first is the train data set, which is used for the training our dataset model. And second is the test data set, which we are going to utilize to evaluate the performance of the final train model. And third is the validation data set, which is used during the training phase to fine tune our models hyper parameters and prevent overfitting. So those of who don't know what is hyperparameter, so hyperparameter is the external configuration settings that are not learned from the data but are set prior to our training process. So these parameters influence the overall behavior of a machine learning model and impacting how the model learns and generalize from the training data. So we are going to basically split these three. We need these three data set: training data set, test data set, and the validation data set. So first we will split the our main data set into training data set and the test data set, and then the remaining part of the our training data set we again further split into training final training data set as well as in the validation data set. So for that, first we need to import the skit library, sklearn library. So that is a machine library for predictive data analysis. So let do that. I hope the screen is visible to you. Yeah. So this is the same notebook which we have utilized in the previous video. So you can check that link will be available in the description, or you can go to my live section of my YouTube channel and check that out. So we are further carrying out our uh, video. So to import that, so to scikit library to import it. So we are going to utilize the model selection feature of that. So for that, we will use sklearn dot model selection. So you can see it as it is already there. So we can, and we are going to utilize the train test split function. So basically, this train test split function is a function from scikit learn library, as I already told, which is commonly used for splitting data set into training and testing sets, which we are going to do here. Okay, so let me press shift enter to execute this. So this is we have imported this function, and now it's time to utilize this function into our for our work. So to do that, we are going to let me just use this function with train test split. And so function, we have to put the parameters inside it. So I want to split our x. So you already know, like let me show you it again. So X, when we imported our main data set, adult data set, we can see we have imported like this. First, we imported it has two parts. First is the features, and then second is the label. Then we have separated X as the features and Y as the labels. So you can see it is when we say display X and Y, so it displays X as the all feature matrix and Y as the label vector. So now you can see, so I want to split X and Y. Okay, so this I have, and to specify the size, like how much test database size you want, or how much uh, like a training data set size you want, you have to utilize this parameter train test size, and we will put 0.2. That specify means like a test data set will be of 20% of the total size. So here we are specifying the size of the test data set, and so 80% automatically will become training data set. And then we will also utilize the random state. So I will explain. Just we can put any number. I here generally put as a seed as one. So now let me explain what each terms in. So as I already told, X is the original feature matrix which we imported as a adult data set, and Y is the label vector. And using this test size, we are specifying the 20% of their data should be used for the testing, and remaining 80% for the training purposes. And lastly, this random state one, it ensures the reproducibility by fixing the fixed seed. Okay. So what does it mean by that? If we set this random state parameter to any specific value, such like here we specify as one, so it ensures that the random number generated in the code are same every time. Means whenever I run this, they this random state one, then there will be a randomization, but it will be always same uh, uh, like uh, well, if I let us run it, so it will be like when I show you, it will be better for your understanding. Okay, so just like we did earlier, also like we split the features and the labels. So similarly, here we are going to split all the features and the label for all of them. Okay. So first we have to put the features of training data set, then features of the test data set, then labels of the training data set, and then labels of test data set. Okay. Okay. So this looks fine. Yeah. So let me run it, and now run display. So let me show you what was the original matrix first. Okay. Let me just run it. So this was the original matrix, and now what is the original feature matrix, and then if I check the training matrix, so you can see it is now randomly splitted. But as I run it as a random state one, so every time I run with this one, it is going to give me this matrix only, starting from 16465 and 29733. But it will be a randomize, because I have not programmed it, but every time I will get a same. If I put it 2, it will give me a different result. If I put it 3, it will again give me a different result. But if I want to utilize it later stage, what result it give me at the when I put the random state equal to 1. So that's why we are utilizing this random state parameter here, because this makes the result reproducible. And this randomness is basically we are controlling using this fixed seed. Okay, so it ensures that the random number generated in the code are the same every time you run it. I hope this is now clear. So we have seen the X train. Okay, then let's see X test as well. So you see, like remaining part, 20% is here. You can see the rows. It is reduced from the earlier, and 80% part is here in this X training data set matrix feature. Okay. And then let's see, we have seen the test data set and now see the labels as well. We so this is the original label vector. Now the training label vector is this, because it is like we will not be able to like differentiate in that term, but it has already splitted into similar manners, like 80% labels is on the training data set and the rest is on like test data set. So I hope this is like much clear to you guys. So like now we have the training metrics for the training data, feature metrics for the training data set, and the feature metrics for the testing set, and the labels for the training set and the labels for the testing set. So now we have two data set, training data set as well as testing data set. Now we have to further split this training data set into a final training data set and the validation data set. So again, we are going to utilize this same thing. So let me just uh, like copy paste it from here, and just instead of test, I'm going to put a validation here. And here in splitting, instead of the original X matrix, I'm going to utilize X training and Y training. Okay. And here I'm going to like test size I put 25% and rest 75% will be on like validation side. Okay. So let's use this and click shift enter. So here I did it, and now let's see the final training data set. So you can see earlier X train is equal to this before splitting, and it has 26,048 rows, and now it has only the 75% of that, that is 19,536. Rest we have splitted into validation data set. Okay, so this one you can see this, it is like we have controlled the randomization using this random state. And so these is the like feature metrics for the training final training data set, validation data set. This is for the test data set. So we have correctly splitted it. And okay, now we can see the labels for it as well. So X train, okay, Y train, and Y validation. Okay, so now we have like fully splitted it. So now after this, we have also seen the display data set, which is specifically used for the display purposes. So now we also align these data set for the display purposes. So for to align it, first we have to know about like how we can fetch the index of the training feature matrix, so that we can utilize it to identify corresponding data for the training set indices. So for that, we will display the x train dot index. Okay. So here you can see, like I will, this is the x validation, and I will get all these indexes of the final training data set. So here I utilize it. I am I am doing it so I can like fetch like that particular which is got splitted into this training final training data set, and I will put it align the display data set according to it. Okay, because currently display data set is also fully main only. Like we have not splitted the display data set. So we have to align the display data set as well. So display data set is basically where like non-numerical characters is there, like never married and all this. But if you look at the like a non like numerical data set, it sets for it represent never married is represented by is represented by 4 and all like numerical numbers. But in display data set you can see this one. So where we put display equal to true, it shows the like display into a characters which will be more suitable for the display purposes, for the administrator purposes. Okay. But for like model training we require because we have to perform the statistical operation, we have to utilize it. So like after we have displayed the training index, then we have to like I hope till now everything is clear. So now we have like we know how we can fetch the indexes of that. So we will fetch out the particular that row, and we'll take and align according to for all the display uh, data set. So for that we will utilize the log function, which is basically a location function. So it it's so in context of panda library, so log stands for the location, and this function is used for label based indexing in the pandas data frame. It is like primarily used to access a group of rows or column by labels or a boolean array. And this name log or loc is chosen to imply selecting data set based on its calculation using labels or boolean condition. So we are going to utilize the same here. So what we are going to do, we are going to like if so so earlier training data set for the display purpose equal to, so here is the original display data set. So I'm going to put out the location for that according to what indexes I have for this current finalized training data set. Okay, so I'm going to copy this and put it here. So it will go to all these indexes and fetch out in the like original display data set, which is this one, and we'll check, okay, this is this line, so let me align it accordingly. Okay, so it will align it, and let me also showcase what is this. So if I going to display X train display, so you can see like this is the like original final training data set in the numeric features one, but here it is same for the display purposes. So here you can see like United States is represented by 39, but here it is for display purposes, it is clearly stated as United States. So we have particular fetched out that particular row only. So that how we like we are basically aligning it the display data set according to the numeric data set. So similarly, we will do it for the test data set as well as the validation data set. So let me just simply do that for the test. So here you can see this. mm, this is the like 96462,639 is the numeric uh, feature matrix, and here is the display feature matrix. Same 936 6,513 rows. Same here in the testing side, 6,513. Similarly, I will do for the validation as well. Let me just copy paste it. Okay, so here is the validation data set, which has 6,512 rows, and similarly, it has put for the displayed purposes. So now we have all aligned with the all type of databases. So let's come and like concatenate all these numeric features with the true labels. So what do I mean by that? Like we are going to basically concat means addition. We will add as a first column all those labels, so we can like use it for our model training and uh, tell our model like this is our data and you have to utilize this to predict the incomes for other people. Okay, whatever the data we provided. So so to do that, first we will import the Panda library as short form. So it is already there, but I will use it as a PD. So let me do that, and then I will create a data frame series, and then I will wait. Yeah, I will utilize it as a number and series of x dot train x underscore train dot index. Yes. So you can see I get the all labels for in a series format for my training data set. So if you look at here, my training data set, yeah, this one only, like this is display purpose, but that is fine for me. So it is starting from the 10911223608. So you can see it is there and same like 19,536 rows. So here you can see the length is that. So basically I made a series of that, but align add it with make a series with the labels, because currently this is in the feature. So I add it both of them and make it as a data frame series. Okay. And what will I will do now? Let me give it a name. So to give it a name, we just need another parameter, which is name only. So we can, which is the name of our label. So you can put anything, because here, like we are looking for income of more than 50,000. So I will put it like that. Press enter. So you can see a name parameter is also added here. So it just set the name of the what data frame series which we are you going to utilize. So as we can see now, the data type is currently in the Boolean format. So we have to convert into integer, because that is useful when we are preparing for data for like machine learning tasks where like specifically these data parameters are required. And this also help us to do calculation easily if this will be in like a numerical format or integer format instead of that Boolean data type. Okay, so what will I do? I will just add in another parameter where like I will change this d type bool into integer. Oh, wait, I given an extra space. Wait, I okay. Here I put colon somewhere. Okay, so now you can see true is represented by 1 and the false is represented by 0. So it will be more easier for like model to calculate and to train itself. Okay. So this after this we have done. Now we what we will do, we will concatenate or basically add these labels series as the first column of our data frame, and which allow us to give easy reference to target variable during our analysis and modeling. So what I will do, I will create it, concat it. So I will concat, yes. Okay. So I will first give that only like what I want to put into a series, what I want to concatenate basically. So first I will just copy it because I want to add it as a first column of my series. So and I want to concatenate it with x underscore my training data set. Okay. And I want to add it along the column if I want. So for add it in a column, I have to put x is equal to 1. If I want to add it in a row, which like is a default, even if you don't put it, it will take axis as 0. So it will add at the top of your uh, like matrix or like table and add it in a row format. But if I put x equal to 1, it will add it as a column. Okay. Now let me press as it and let me just show it. So you can see like this income equal to 50 equal to k is now added. Like okay, so this all these data set is now added as label and like features are added in a same data set. So it will be more easier for our data set to be trained. Okay. So I hope this is clear now. Similarly, we do it for our test data set as well as the validation data set. So for that, I will do this. I will just change the variables because we have already put the same. Okay, so 9,536 and 65,513 with first column as income label, income greater than 50k. So if I go to test, yeah, 6,513 and validation so should come as 6,512. So for validation also, I will do the same. Okay, me copy paste it. Validation, validation. Okay, now let it display also. So 6,512. So now we have all data in the numerical format. Also, we have aligned the display data set and we have like a concat the labels and features into a same data set. So like let's close this video till here only because it's getting too much longer. So see you guys in the next video and we will continue this project and in the next video we are going to train our model, then we will evaluate it. That's why we splitted all these data set for different like to evaluate our performance to test it. So keep watching this and like put more focus on this, and if you have any doubt I will be there. So make sure to like subscribe the channel and like this video.